Hi there, welcome to the third video on the integration topic at higher. Today we're looking at differential equations. So there's a couple of things you need to know from this video. Being able to identify what a differential equation is and recognise the need to integrate in that situation. Be able to integrate to find the general equation for the original function, and then be able to substitute values to find the value for the c, the constant of integration. Okay, so I'm going to give you a couple of examples to try here, chat through them, and then yeah, hopefully that'll do us. So a differential equation is an equation that involves a derivative like dy by dx or something that gives that equivalence. Now, to solve it, we need to find an expression for the original function. So we're looking at being given your derivative, your f dash x, and being able to work our way back to the original function for f of x or y equals. Okay, so to do that, we know we need to integrate. Okay, so in this one here, example 1, we're asked to solve dy by dx is equal to 3x squared minus 5 if x equals 1 when y equals 3. Okay, now dealing with that first part of the question first, if we're looking to solve this, we want to take dy by dx and turn it back into y equals. Okay, so dy by dx equal to 3x squared minus 5. We know that y is equal, going backwards there, the integral of 3x squared minus 5 integrated in respect to x. Okay, so doing that, y is going to be equal to 3x squared. X squared becomes x cubed divided by 3 is just going to be x cubed minus 5x. But we also have this constant of integration we know we need because there's because we don't know if there was sorry, I'm losing my words. We don't know if there was a constant involved in the original term. Okay, now we call this the general equation, the general solution, because that is a solution, but we just don't know what c is. Now, to find out c, we've got another bit of information. That may take a couple of different forms. It might take the form of a coordinate, or in this case, just telling you x equals 1 when y is 3. Now, if we know x is 1 and y is 3, that means we can substitute these points in. So y is 3, x is 1, and that will leave us an equation we can solve to find out c. So 3 is equal to minus 4 plus c, so c is equal to 7, which means our particular solution in this case, y is equal to x cubed minus 5x plus 7. That is us solving that differential equation. Okay, so going back to the success criteria, we need to know firstly that this is an integration question. We then need to integrate, and specifically for differential equations, we need to know to substitute in to find the value for c. Okay, looking at a second example, the gradient of the tangent to a curve is given by dy by dx equals this, and if the curve passes through the point 14, find its equation. Okay, now even if that dy by dx wasn't here, we would need to know that the gradient of the tangent is equal to the derivative. So if I want the equation of the original curve, that's going to be y equals, it's equal to the integral of what we have there. So it's the integral of x squared plus a half plus 2 over x squared. First thing we recognise is that x squared in the bottom is going to cause us a bit of an issue. So I'm going to rearrange this equation. It's going to be x squared plus a half plus 2x to the minus 2 with respect to x, and then integrating that is x cubed over 3 plus half x plus 2x to the minus 1 divided by minus 1 plus c. Okay, which rearranging to use, y is then going to be equal to x cubed over 3 plus half x minus 2 over x, dealing with the 2 divided by minus 1 and then the negative power, plus c. Okay, so then we've got a bit of information to find out c. From any point, we know we can take an x and a y value. So y is equal to 4 when x is equal to 1. And then we can solve that equation. So 4, and here we have a third plus a half minus 2. Okay, so you just need to calculate that. So 4 is equal to minus 7 over 6 when you complete that sum plus c. which means c, add 7 over 6 onto both sides, is 31 over 6. Okay, and then just completing the solution, that means y, excuse me, sorry, y is equal to x cubed over 3 plus half x minus 2 over x, and we now know c is 31 over 6. Okay, so that's your solution for this differential equation at that given point. Okay, now success criteria again, identify differential equations and recognise need to integrate. So when you're given the differential and you're asked for the either to solve it or to go back to the original curve, we need to know that as an integration question. We need to be able to integrate to get the original function and then substitute values for x and y to find that value for c. Okay, that's video 3. Thank you very much.